We know that volume, the number of moles, pressure, and temperature are the four interrelated properties that describe the behavior of gases. The relationship between these properties is described by three laws. They are Boyle's law, Charles' law, and Avogadro's law. Boyle's law describes the relationship between pressure and volume. It states that volume is inversely proportional to pressure at constant temperature and number of moles. Charles' law describes the relationship between temperature and volume. It states that volume is directly proportional to temperature at constant pressure and number of moles. Avogadro's law describes the relationship between volume and number of moles. It states that at constant pressure and temperature, the volume of a gas is directly proportional to the number of moles present in the gas. On combining these three laws, we get the ideal gas equation. However, when we introduce a constant of proportionality, R, then the equation can be written as V is equal to R into N into T divided by P. Here, R is known as the universal gas constant. To find the value of R, we need to rearrange the equation and substitute appropriate values of P, V, N and T. For example, under standard conditions of temperature, that is 0 degrees Celsius or 273.15 Kelvin, and pressure, that is 1 atmosphere or 101.3 kilopascal or 10 to the power of 5 Pascal, 1 mole of a gas occupies 22.4 liters or 22.4 cubic decimeter. On substituting the values in the equation, we can get the value of R as 8.314 joules per Kelvin per mole. We have learnt that ideal gas equation is a relation between four variables: volume, pressure, temperature, and number of moles of a gas. If we vary temperature, volume and pressure of fixed amount of gas, that is, keeping the number of moles N of the gas constant from T1, V1 and P1 to T2, P2 and V2, then using ideal gas equation, we can write P1V1 by T1 is equal to NR and P2V2 by T2 is equal to NR. Combining the two equations, we get P1V1 by T1 is equal to P2V2 by T2. This equation is known as combined gas law and is useful in performing calculating of any of the variable if other 5 variables are known. So far, we have identified the relationship between volume and the other interrelated properties using the ideal gas equation. Next, let's move on to learn about an equation that relates density and molar mass for gas. To understand the density and molar mass of a gaseous substance, we have to rearrange the ideal gas equation to N divided by V is equal to P divided by R into T. On replacing number of moles N with mass of the gas M by M, we get the equation M divided by M into V is equal to P divided by R into T, where M is molecular mass of the gas. We know that M by V is equal to D. where D is the density of the gas. Thus, we can rewrite the equation as D divided by M is equal to P divided by R into T. On rearranging the equation, we get the relationship to calculate the molar mass of gas as M is equal to D into R into T divided by P.